So in this problem, it says that Manuel made $1,050 working all summer. We're going to use the table to describe what happens. First, we find the rate of change. All of my jumps in the left-hand column are going up 1. All of my jumps in the right-hand column, my Y column, are going down, so it's minus 50. That makes my rate of change negative 50 over 1, or negative 50. I have to include my units, dollars per week. In the first problem we looked at today, Shauna was saving money, so our rate was positive. Now we have Manuel spending money, or using money, which puts his rate as a negative number. So that's why it's negative. It means that Manuel is spending $50 each week. Number 7 asks us to find the starting point. Remember, when I'm looking at the starting point, I'm looking for the ordered pair where x is 0. In that case, it is the first one. So at 0, it's 1,050, which means that Manuel started with $1,050. We looked the other day at function rules and how I can pick the rate of change or the slope out of a function rule, and how I can pick the starting point out of the function rule. We can do the same thing in reverse. Remember, as long as we had our equation in function form, we were able to pick out the rate and the starting point. And all of that came from your rate is what you multiplied x by. So here, I'm going to write my function rule. My rate is negative 50. So I'm going to say y equals negative 50 times x. My starting point was 0, positive 1,050. Because it's positive, I'm going to add 1,050. That is how I can write a function rule if I know the rate and I know the starting point. From there we can go ahead and use that function rule. I can use it to find out how much money he will have after 15 weeks. We had said that x was the number of weeks, so if x is 15, substitute into our function rule and find y. So y would be equal to negative 50 times 15 plus 1,050. I go ahead and I calculate that. You guys should be calculating that right now. And yes, he has $300 after 15 weeks. In number 10, when they ask, when will they run out of money? Running out of money means you have no money left, or $0. So y was the amount of money, so running out of money means y is 0. I use the same function rule, but now I substitute 0 in for y. So instead of y equals, it's 0 equals negative 50x plus 150, or 1050. And I solve for x. Those are the algebra skills we learned at the beginning of the semester. Subtract 1,050 first. Negative 1,050 equals negative 50x. So when you divide both sides by 50, you get x equals 21. which means he will run out of money after 21 weeks. And you do need to have the labels because the problem has those labels in it. Two questions with number 11. How would the function rule change if he spent $100 a week? And how would the graph change if he spent $100 a week? First, let's talk about the function rule. This is our function rule when he's spending $50 a week. So hopefully we would see the only difference in the function rule would be with the rate. And instead of it being negative 50x plus 1050, it would be negative 100x plus 1050. Second, with the graph, your original graph would be starting up at the top, and it would be going down because it has a rate of negative 50. And you see he's losing money. That would be the original graph. But if he changed to $100 instead of $50, your new graph would start at the same spot. But do you think it would be going down faster or going down slower? Would it be steeper or less steep? Yep, it would actually be steeper because if you think about how fast he's losing money, he's losing it faster. So it doesn't hit 0 after 21 weeks, it would hit it much faster. Okay, the next video we'll look at the third page of our notes.